Today is part 2, talking about the method of undetermined coefficients. And the goal for today is to completely solve some non-homogeneous differential equations. To completely solve a non-homogeneous differential equation, all you need to do is find the complementary function and find one particular solution. Then the general solution can be found by adding these two together. So I will be demonstrating the technique in 2 examples. Now please be warned, the problems in this section are generally speaking extremely long, so just brace yourself. These problems can take a long time. Alright, let us describe all solutions to the differential equation y double prime minus 10y plus 25 is equal to 10x plus 2. So I'm going to break this down into a couple of different parts. Step 1, I'm going to find the complementary function y sub c. Which means that I'm going to solve the differential equation that I get if I set the right-hand side, some typos here. If I set the right-hand side of this differential equation equal to 0. Now this differential equation has constant coefficients. So I'm going to guess that my solutions have the form y equals e to the rx. So I get the auxiliary equation r squared minus 10r plus 25 is equal to 0, which factors as r minus 5 twice. So I have a repeated root of r equals 5. So my complementary function must have the form some quantity e to the 5x plus some number times x e to the 5x. This is my complementary function. So now that I've found y sub c, my next task is to find y sub p, the particular solution, a particular solution to this differential equation. And in order to find a particular solution, I'm going to use the method of undetermined coefficients, which says guess a solution of an appropriate format. Now for a particular solution, I'm going to turn my attention on the function on the right side. In this case, my function is a polynomial of degree 1. So I'm going to make my guess another polynomial of degree 1. I'm going to guess that it's some number times x plus some number. So this would make yp prime equal to just a and yp double prime equal to just 0. So if I plug that guess into my original differential equation, then I get negative 10 times a plus 25 times ax plus b, and my goal is to make that equal to 10x plus 2. Let me simplify this and let me organize it according to which terms have x's and which terms are constants. My goal is to make 25ax, those are the x terms, equal to the 10x on the right side, and my goal is to make the negative 10a plus 25b, the constants on the left, equal to 2, the constant on the right. So this is going to imply that 25a is equal to 10, and negative 10a plus 25b is equal to 2. If I look just at the constants. So that implies that a is 10 over 25, or 2/5. And let's plug that into our secondary equation. Negative 10 times 2 over 5 plus 25 times b equals 2. So negative 4 plus 25b is equal to 2. So 25b is equal to 6, and therefore b is 6 over 25. So having obtained 2/5 for a and 6 over 25 for b, I can fill in the undetermined coefficients in my guess at a particular solution. The particular solution has the form 2 over 5 times x plus 6 over 25. Finally, we have everything that we need to construct the general solution. We can solve the original ODE, which is the same thing as find the general solution. Any solution to my original differential equation must have the form of the complementary equation c1 e to the 5x plus c2x e to the 5x plus the one particular solution 2/5 x plus b was 6 over 25. Every solution to our non-homogeneous given ODE must have this format. So, solving a non-homogeneous ODE is a three-step process. Step number 1 is convert the ODE to its homogeneous equivalent with 0 on the right side. Then solve that completely to get you the complementary function y sub c. Then use method of undetermined coefficients to cook up a particular solution. Guess a solution of a format similar to the function on the right side of your equation, and try to use algebra to figure out the values of those constants. And finally, in your final answer, put together your complementary function and your particular solution from steps 1 and 2. So let's do another example. Let's solve the non-homogeneous differential equation y double prime plus 2y prime minus 24y equals cosine of 2x. So in order to describe all the solutions to this differential equation, the first thing that I need to do is find the complementary function. So let's set the right-hand side equal to 0 and solve. Once again, we have a differential equation with constant coefficients. So we're going to guess that our complementary solutions have the form y equals e to the rx, which gets us the auxiliary equation r squared plus 2r minus 24 equals 0. And if we factor that, we get that r is equal to 4, where r is equal to negative 6. So our complementary function has the form c1 e to the 4x plus c2 e to the negative 6x. Now that that's complete, let's move on to step 2, which is trying to find one particular solution. So let's guess a particular solution which is of a format that's similar to the function on the right side of my ODE. Now the function on the right side of the ODE is a trig function with a 2 on the inside, and so the guessing table from yesterday's material suggests that we should guess a combination of cos 2x and sine 2x. So with that guess, yp prime would be equal to negative 2a sine 2x plus 2b cos 2x, and yp double prime would be equal to negative 4a cos 2x, negative 4b sine 2x. So let's go ahead and plug this guess into our differential equation. Y double prime plus 2y prime minus 24y will become y double prime plus 2y prime minus 24y is equal to cos 2x. So I'm going to go ahead and combine like terms and arrange them according to which terms contain cos and which terms contain sine. So those are the cos terms, and here are the sine terms. So, negative 4 plus 4b minus 24a must be equal to 1 if I look at the constants on the cosines. So if I combine as many like terms as possible, negative 28a plus 4b must be equal to 1. Now on the left side I have negative 4b, negative 4a, and negative 24b. Those are my sines. But on the right side I have 0 sines. Now, it looks like I can actually solve this one pretty easily by substitution. If I take the second equation and I solve for a, I find that a is equal to negative 7 times b. So if I stick that back into the first equation, negative 28 times negative 7b plus 4b is equal to 1. Uh-oh, calculator time, hold on. So that works out to be 200b, that's cool, equals 1. And therefore b is equal to 1 over 200. Now if I combine that with the fact that a is equal to b times negative 7, that means that a is equal to negative 7 over 200. And so if I put those values back into my guess at a particular solution, then the particular solution is going to be equal to a times cos 2x plus b times sine 2x. Having finally obtained both a particular solution and our complementary function, we can solve the ODE, we can find the general solution by putting the results of step 1 and step 2 together. C1 e to the, I already forgot what the complementary solution was. Hold on. It was e to the 4x, e to the negative 6x. And our particular solution was found to be negative 7 over 200 cos 2x plus 1 over 200 sine 2x. Incredible. Beastly, wasn't it? So that is the process that's involved in solving non-homogeneous differential equations, finding general solutions. Now, I'll be the first to admit that these problems are incredibly involved, and there are lots of places where things can kind of go wrong. But I tell you what, this is the best mathematical workout you're going to get in undergraduate, I think. If you can get through these calculations, you are ready to calculate anything, really. This is what transforms a person from a mathematical child into a mathematical adult. So this concludes today's material. We practiced finding the general solution to a non-homogeneous ODE by first finding the complementary function, then finding one particular solution, and then combining those to get the general solution.